Welcome to another episode of the Part 145 EASA training from Phoenix Way Academy. Hi, I'm Sarah.
Hi, and I'm Sam.
Well, in this deep dive, we're tackling the topic of 145.A.42 components. And this is a big one, so it'll probably take us about 3 sessions to get through properly.
Okay, great. Yeah, components. When you think about an aircraft, the big things come to mind: wings, engines, pilots even.
Right.
But the reality is it's all built from thousands, maybe millions of individual components. And understanding how every single one, down to the nuts and bolts, is classified and managed. Well, that's not just paperwork.
No, not about.
It's fundamental.
Yeah.
Fundamental to safety, to compliance, and it really is the hidden system keeping planes flying safely. So today we're diving into that meticulous world, component classification and management, under EASA Part 145.
Exactly. And Clause 145.A.42, that's our focus. It really lays the groundwork. It sets up these distinct categories for every component imaginable. And this classification system, it's just crucial for handling them correctly, maintaining them, and, ultimately making sure they're airworthy. It brings order to a potentially very complex supply chain.
Okay, so the core idea.
Yeah.
All components get classified. Let's start with the first category, that 145.A.42A1. Components in satisfactory condition. What does satisfactory really boil down to here?
Yeah, satisfactory is more than just, looking okay. It means the component has an official green light. It's airworthiness passport, if you like.
Okay.
Primarily, this means it's released on an EASA Form 1, or an equivalent document we'll talk about. And it has to be marked properly, according to Subpart Q of Annex I, that's Part 21, to Regulation EU number 748/2012.
Right.
Basically, it's the official stamp saying, yes, this part is airworthy, traceable, and compliant. Unless, of course, there are specific exceptions mentioned in other rules like Part M or Part ML.
So, if a maintenance shop gets a brand new part, maybe an engine component, it could look absolutely perfect, shiny, new out of the box. But if it doesn't have that valid EASA Form 1 or an accepted equivalent document...
Then no, it cannot legally be installed on an aircraft. That form is the proof. Proof of airworthiness, origin, conformity. It's foundational trust, really.
Got it. Foundational trust. I like that.
And this leads us nicely into the acceptable means of compliance, the AMC, specifically AMC 1145.A.42A1. This tells us what else counts as equivalent to that EASA Form 1.
Ah, okay. So there are alternatives. Why is that?
Well, it's because aviation is global, isn't it? EASA works with other authorities. So this AMC recognizes documents from, say, countries that have bilateral agreements with the EU.
Right, international partners.
Exactly. Or documents issued under older JAA agreements before they were replaced by EU ones. It even covers older JAA Form 1s issued before specific dates, like 28 November 2004 or 28 September 2005 for certain production organizations.
Okay. So it acknowledges history and international cooperation.
Precisely. And there's also a mention of a declaration of maintenance accomplished for certain Part M or Part ML scenarios. It ensures continuity. Apart from the U.S., under a bilateral deal might arrive with an FAA form, and that's accepted. It keeps the global supply chain moving safely.
Okay, that makes sense. Now, what about guidance material, the GM? You mentioned GM 145.A.42A1. What light does that shed? You said it wasn't binding.
Right. GM isn't the rule itself. It just helps explain it. This GM points us to specific parts of the Part 21 regulations, 21.A.307B and 21L.A.193B. These sections detail which new components actually don't need an EA Form 1 for installation.
Ah, so there are exceptions for new parts.
Yes. Typically for, let's say, simpler, lower-risk items. But, and this is key, they still need documentation. Point C, in those same Part 21 sections, specifies the conditions for that accompanying paperwork. It has to prove conformity.
So maybe like standard fasteners or certain types of connectors.
Exactly, things like that. The documentation might cover a whole batch, ensuring traceability, but without needing an individual Form 1 for every single tiny part. It streamlines things where it's safe to do so.
Okay, streamlined but still traceable. Got it. Let's move to the second classification then. 145.A.42A2, unserviceable components.
Right. Unserviceable. It simply means a component isn't currently fit for installation. It's not necessarily scrap.
But it's definitely not ready to fly.
Correct. The crucial point is that it can become serviceable again. It needs maintenance, repair, or overhaul, following the procedures laid out in Part 145.
Okay, so an example might be, say, aircraft brakes that have hit their cycle limit for overhaul.
Perfect example. Even if they seem to work fine, the maintenance program says they're due. So legally, they're unserviceable until that overhaul is done and they're certified again.
Makes sense. You stick to the limits.
And managing these parts is covered by AMC 145.A.42A2. The first point, A, is all about identification.
Tagging, right.
Yes, clear and robust tagging. It's absolutely essential. The tag has to state its status unserviceable and include key information. Things like known defects, maybe hours or cycles if relevant, if it was involved in an incident.
And it mentions preventing the tag from separating.
It does. You need a physical means to keep that tag securely attached. So if a part comes off an aircraft because of a reported issue, bang, it gets an unserviceable tag immediately. Details the fault, where it came from, prevents it ending up back in the good stock by mistake.
A fundamental safety step.
Absolutely. And point B of this AMC lists the typical reasons why a component gets tagged as unserviceable. There are 5 main ones.
Okay, what are they?
1, expiry of its service life limit, like our brake example. 2, it doesn't comply with an airworthiness directive, maybe needs a mandatory mod or inspection.
Right, 80s are critical.
3, lack of necessary airworthiness information. Basically, lost paperwork or unknown history. You can't use it if you don't know its status.
True. No history, no fly.
4, it has obvious defects or malfunctions, leaks, cracks, doesn't operate correctly.
Pretty straightforward.
And 5, it was involved in an incident or accident. Any part coming off an aircraft after something like a hard landing or bird strike needs checking, so it's deemed unserviceable until proven otherwise.
Okay, that covers a lot of ground. Expired life, non-compliance, no info, defects, or incident involvement.
Got it.
Now the third category, 145.A.42, 3, unsalvageable components. How's this different from unserviceable?
This is the end of the road for a component. Unsalvageable means permanently unfit for use. It's scrap, period.
No coming back.
No coming back. Either it's hit its mandatory absolute life limitation, like fatigue life, or it has a non-repairable defect. Damage beyond any approved repair scheme.
So if a critical structural part has a crack that the manual says can't be repaired, or maybe a turbine disc reaches its maximum allowed cycles.
That's it. Unsalvageable. And these parts are often deliberately mutilated, maybe drill holes in them, damage the data plate to ensure they never accidentally find their way back into the supply system.
Wow, okay, a definitive M.
The fourth category is standard parts.
Like nuts and bolts.
Exactly. Nuts, bolts, washers, rivets, common hardware. These are used when the maintenance data specifies them, and they need to come with evidence of conformity traceable to a recognized standard.
So they don't need an EOS Form 1 individually.
Generally, no. Their airworthiness comes from meeting established industry or military standards, think ANMS standards. The crucial thing is the documentation proving the batch they came from meets that specific standard. Traceability to the standard is key.
Okay, so for a standard bolt, it's about proving it meets, say, the AN specification it's supposed to.
Precisely. You need the paperwork confirming its batch conformity. It relies on trusting the manufacturing process for these widely used standardized items.
Right, and the fifth and final classification is Section A. That's AV material.
Yeah, this covers both raw materials like sheets of metal, lengths of wire, and consumable materials, sealants, paints, oils, cleaning agents, that sort of thing.
Okay, what are the requirements here?
The organization using them has to be satisfied, they meet the required specification, and again, have appropriate traceability. All material needs documentation. It has to clearly relate to that specific material batch, state conformity to its spec, and list the manufacturing and supplier source.
Traceability again. So if you buy a roll of aircraft-grade wire,
it needs to come with paperwork. Spec number, batch number, manufacturer, supplier, statement of conformity. You need to know it's the right stuff and where it came from, ensuring it will perform as expected in flight.
Makes perfect sense. So that's the 5 categories under 145.A.42A: serviceable, unserviceable, unsalvageable, standard parts, and materials. Quite a comprehensive system.
It is. And this clear classification, backed by the rules around documentation and tagging we've discussed, it really is the foundation for managing components safely and ensuring compliance. Knowing exactly what you have is step 1.
Okay, so knowing what category a part falls into is step one,
Yeah,
but then you actually have to do something with it, right? Like install it.
exactly. And that brings us to the next part, section B of 145.A.42. This deals with components, standard parts, and materials for installation. It's about the procedures.
Procedures for installation. Okay, what's the first point?
Point B, I says, the organization must establish procedures for the acceptance of components, standard parts, and materials. This is to make sure that when they arrive, they are indeed in satisfactory condition and meet all those requirements from Section A we just talked about.
So a formal receiving inspection process is mandatory. It's not just signing off on a delivery note.
Absolutely not. It's a critical check. Verifying the paperwork, the EASA Form 1 or equivalent, checking part numbers, serial numbers, looking for shipping damage, ensuring correct labeling. It's the gatekeeper function before a part even gets into the store.
Right, the first line of defense. Catch problems early.
Precisely. So that new spare part arriving, it gets thoroughly checked before it's accepted into inventory as serviceable.
Okay, and then point B, this seems to be about the actual installation step.
It is. It says the organization needs procedures to ensure parts are only installed if they meet 3 criteria. 1, they're in satisfactory condition. 2, they meet the applicable requirement of point A. And 3, the applicable maintenance data, the manual specifies that particular component, standard part, or material for that specific location.
So it's not enough that the part was accepted okay earlier. There's another check right before it goes on the aircraft.
Yes. A final verification. Is it still satisfactory? And crucially, is it the exact right part number called out in the aircraft's maintenance manual for that specific job? It's about preventing installing the wrong part, even if it's a perfectly good serviceable part of a different type.
So the mechanic installing, say, a fuel pump, needs to double-check its part number against the manual for that aircraft, that engine position.
Exactly right. Cross-reference the part number, serial number sometimes, against the illustrated parts catalog or maintenance manual. Absolute precision is required.
Makes sense. Okay, what's next? Point B3 talks about fabricating parts.
Yes, it allows an organization to fabricate a restricted range of parts, but only for use during work within its own facilities. And crucially, only if the procedures for doing so are identified and approved in their Maintenance Organization Exposition, the MOE.
So they can make some simple things in-house, but it's tightly controlled. Not like becoming a parts manufacturer.
Definitely not commercial manufacturing. It's for specific limited needs during a maintenance task. Maybe making a simple bracket, or cutting and fitting a specific length of wiring conduit during a repair, rather than ordering a standard length. But the how-to materials, process, quality control must all be documented and approved in their MOE.
Got it. Limited, controlled, and documented. And the last point here, it refers back to Part 1 again.
It does. It mentions specific components covered by point B2 of 21.A.307 in Part 21, or the equivalent in Part 21 Light. For these specific types, they can only be installed if the aircraft owner considers them eligible for installation on their own aircraft.
That sounds quite specific. What kind of situation is that for?
It's often more relevant in, say, general aviation or for certain types of non-commercial operations. It might cover things like owner-produced parts under specific conditions or certain minor modifications. The key is that the eligibility assessment falls primarily on the owner for their specific aircraft, obviously still within the overall safety regulations.
Okay, so a specific allowance, mainly for owner-involved situations in GA, perhaps.
Generally, yes. So wrapping up Section B, it's all about having documented procedures for acceptance and installation. Layers of checks to ensure only the right compliant parts get fitted. Safety, safety, safety.
Absolutely. Okay, one final section for today under 145.A.42, Section C. Segregation of components.
Yeah.
Seems straightforward, but critical.
Very critical. Point CI is simple but vital. Unserviceable and unsalvageable components shall be segregated from serviceable components, standard parts, and materials.
Physical separation. Keep the good stuff away from the bad stuff.
Exactly. It prevents mix-ups. You don't want someone accidentally grabbing an unserviceable part from the wrong shelf and installing it. It sounds basic, but it's a cornerstone of workshop safety.
You see it in any decent hangar, right?
Yeah.
Clearly marked areas or racks. Serviceable here, unserviceable over there, scrap in a locked bin.
That's the idea. Clear physical boundaries to remove any doubt about a component's status.
And then point C2, it deals specifically with the unsalvageable ones.
Right. It states clearly, unsalvageable components shall not be permitted to re-enter the component supply system. full stop.
No way back in.
Well, there's a very narrow unless clause. It says unless mandatory life limitations have been officially extended or a specific repair solution has been approved according to Regulation 145.A.42.
But those are exceptions, right? Major engineering and regulatory hoops to jump through.
Extremely rare exceptions requiring significant justification and formal approval. For all practical purposes, unsalvageable means it's out of the system forever. It needs to be disposed of properly to make sure it can't reappear.
Like we said, maybe drilling holes, destroying data plates.
Precisely. Ensuring it cannot possibly be mistaken for a usable part down the line.
Okay, so Section C hammers home the importance of segregation. Keep things separate to prevent potentially fatal errors.
That's the essence of it. Correct identification and handling at all times, reinforced by physical separation.
All right, so let's try and wrap up what we've covered from 145.A.42 today. We've looked at the 5 key classifications in Section A: serviceable, unserviceable, unsalvageable, standard parts, and materials.
Each with specific definitions and documentation requirements.
The Section B laid out the procedures for acceptance and installation, making sure only the right parts in the right condition get fitted, according to the maintenance data.
Including that crucial final check before installation.
And finally, Section C stressed the absolute need for segregation, keeping unserviceable and especially unsalvageable parts physically separate from the good stock.
Yeah, and when you step back, you see how these detailed rules aren't just red tape. They're the framework that ensures every single part, big or small, on every aircraft is tracked, managed, and confirmed fit for purpose.
It really underpins the entire safety system. It brings clarity, traceability,
And prevents potentially catastrophic errors. It allows this incredibly complex system of global aviation to function reliably.
So, for you listening, what does this all mean? It means behind every single flight, there's this incredibly rigorous system. Checks and balances for every component, ensuring each part does its job safely. Think about the sheer number of parts on a modern airliner.
Thousands upon thousands.
Imagine trying to manage that complexity without these clear classifications, without these strict procedures for acceptance, installation, and segregation. It would be chaos. It's really quite something to consider.
It really is. Okay, I think that's a good place to pause for this session. In the next deep dive, we will continue exploring 145.A.42 components, looking at further details and requirements.
Great. And remember, you can follow us on social media under the name Phoenix Way Academy for updates and more content.
Thanks for listening. Stay safe and stay informed.